Hey everybody! So now we're going to use synthetic division to do something really cool. It turns out that synthetic division can be used to determine what you get when you plug in a number into a polynomial. It's called the remainder theorem. And it's going to turn out that the remainder itself is the numeric result that you get when you replace x with some number. So in this particular instance right here, if this is our function, our polynomial function, and I want to replace x with this k value 2. The old way that we would do that is we would have to find f of 2. And what that would mean is that I would replace the x with 2 and calculate that. That's not too bad in this case. If you do the calculation, 2 squared is 4, minus 5 times 2 is a minus 10 plus the 3, so 4 minus 10 is negative 6, plus 3 is a negative 3, it looks like. Okay, so here's the cool part. Watch this. If I were to do synthetic division on this using the k value of 2, so that means in essence I'm dividing this polynomial by an x minus 2. So if I set up the synthetic division, we're going to place coefficients here, so that's a 1 from the x squared, a minus 5 from the x, and a 3. No skipped terms there, so just bring things down. So now, bring down the first number and start your zigzag process. 2 times that 1 is 2. Add straight down, so negative 5 plus 2 is a negative 3. 2 times the negative 3 is a negative 6. And 3 and negative 6, lo and behold, there's the negative 3 that we got the old way. So this remainder right here is the answer to plugging into that original problem. It's pretty impressive. And the calculations along the way were actually, in some ways, maybe a little bit easier than over here. Now, you could maybe argue that, maybe not. But if we start to up the size of the polynomial, and maybe even up the size of our numbers, well, then it becomes a little more challenging. So like if you look at this one here, if I replace the x with a negative 3, so now I've got to start cubing that number, squaring it, so it gets a little more involved here. So notice that would become a negative 27. That's a positive 9, so this would be 5 times that 9 is 45. And then negative 3 times 2, well, that's a minus 6 and a minus 4. So if I combine all my negatives, that's a negative 10, and negative 27 is negative 37, plus 45, and that's going to turn out to be positive 8. Okay, so not too bad, but check out the synthetic division. If I set that up, so the negative 3 goes in there, I've got a 1, a 5, a 2, and a negative 4. So the advantage here is I'm not having to cube and square numbers and things like that. I can just start my zigzag process, which is just multiply there, write that answer there, and then add straight down. So that's a 2. Multiply again. Negative 3 times 2 is negative 6. Add straight down. That's a negative 4. Multiply once again. Negative 3 times negative 4 is positive 12. Add straight down. There's our 8. And I think that was actually faster. So it's pretty cool. It's a great way, especially if you have a polynomial with higher degrees in it, it's a great way to get the answer that you would get from plugging in a number into the polynomial. You can just perform synthetic division, and the remainder is that answer. It's pretty impressive. So enjoy that.